Hi, my name is Eric Diaz. I'm an engineer here at Agilent Technologies. A lot of customers have asked us how to generate and analyze digitally modulated signals up at millimeter wave frequencies. And this is becoming increasingly important as new applications appear at these high frequencies, things like automotive radar or wireless HD video transmission. So today we're going to demonstrate creating and analyzing a 64 QAM signal at 65 gigahertz. And to do that, we'll be using a PSG vector signal generator, a PSG analog signal generator, an EXA signal analyzer running the 89600 vector signal analysis software. So let's take a closer look at how to set up this measurement. All right, now to generate our signal, let's begin with the vector PSG. We're creating our 64 QAM signal internally and modulating a 15 gigahertz carrier, and that's being output here on the RF output. Now, using the internal baseband generator, we can generate up to 80 megahertz of modulation bandwidth. But some applications require more bandwidth. So in those cases, we use the external IQ inputs on the rear panel and an arbitrary waveform generator that can create up to 2 gigahertz of modulation bandwidth. So that gets us very wide modulation up to 44 gigahertz. But in this case, we want to go up to 65 gigahertz. And so we'll use an upconverting technique. And to do that, I need a local oscillator. So for that, I'll use the analog PSG. It's putting out a 25 gigahertz signal with plus 17 dBm. Now, the reason I use the high-level 17 dBm output is because that helps us get better conversion efficiency in the mixer. Now, to perform the actual up conversion, I'm using this mixer right here, mounted on the front panel. And normally, this would be an option in the analog PSG called option H65. That's mounted behind the rear panel. I'm using it here externally, so it helps us visualize the signal flow quite a bit better. Now, this particular mixer has an integrated doubler, and so that doubles our 25 gigahertz signal from the PSG to 50 gigahertz. We combine that 50 gigahertz signal now with the 15 gigahertz IF from the vector PSG, and that's what gets us to 65 gigahertz. So that's how we generate our modulated signal up at the millimeter frequency. Let's take a look at how we analyze the signal now. Now, to analyze our signal, we'll be using the EXA signal analyzer, which is part of Agilent's family of X-series signal analyzers. This happens to be the 44 gigahertz model, and it has the external mixing option. The external mixer we're using is right here. That's one of our smart mixers, and we call it a smart mixer because it has onboard memory that has all the correction values for this particular mixer stored inside. Now, when I connect this to the EXA, I'm using a USB cable, and when I plug that in, it'll automatically identify which mixer I'm using, and it will download those correction factors into the memory of the EXA. And that corrects for the frequency response of the smart mixer, giving us the very best amplitude accuracy. We also have this RF cable that takes the LO signal from the EXA, runs it to the smart mixer, and then the IF signal comes back through the same cable into the instrument. Now, inside the EXA, we're using the 89600 vector signal analysis software. This is a really powerful software package that lets us analyze a wide variety of signals and modulation types. And you'll note here on the display, we have in the upper left quadrant our familiar constellation diagram for a 64 QAM signal. And then down here, we have all the measurement results that were calculated with the software. And in particular, I'll point out that we have a very good EVM number. It's running about 1.6%, which is pretty remarkable considering we're looking at fairly high order modulation up at 65 gigahertz. So in this short demonstration, we've been able to show how you can generate and analyze a digitally modulated signal up at 65 gigahertz with low EVM. If you'd like to find out more information about Agilent's millimeter wave solutions, please visit the URL shown here or talk to your Agilent sales representative. Thanks for watching.